Thus, the expression for transmission probability becomes particle density of transmitted beam divided by particle density of incident beam, and this particle density is nothing other than the probability for finding these particles. So that are nothing but the square of the relevant part of the wave function. As long as the transmitted intensity of particle is concerned, it is the norm square of the wave function representing the transmitted beam, and that of the incident particle corresponds to the square of the amplitude of that part of the wave function in region 1, that is represented by, say, phi 1 incident, phi 1 with this part, say phi 1 incident. So which this ratio transmission probability is equal to phi 3 square divided by phi 1 incident square, and that is equal to a3 by root p e raised to I by h cross integral x2 to x pd x prime into complex conjugate of this one, which is now a3 star a3 square e raised to minus I by h cross into this one into e raised to I by h cross into this one. So the exponent term vanishes, divided by root p into root p, make it say p. So on the numerator you will have a3 square by p, and the denominator you will have square of this one, which is a1 square divided by p. As the momenta of the incident beam and transmitted beam are exactly equal, the momentum term also will be vanishing and the transmission probability becomes equal to a3 divided by a1 whole square. So in order to evaluate this, we are required to represent a3 in terms of a1 or a1 in terms of a3. Suppose you get a1 equal to something into a3, then you will be able to find out a3 divided by a1 equal to, say, this one, or squaring it, that will give you the square of this constant part that is to be evaluated. For that we follow the procedure that we have formulated on the basis of the connection formulae. Let's consider phi 3, the wave function in region 3 representing the transmitted beam of particles, that is a3 by root p into this exponent, that is a3 by root p into, let me multiply and divide this by means of e raised to minus I pi by 4, that is this is multiplied by e raised to minus I pi by 4 and e raised to plus I pi by 4, that is being added with the power of the exponent part. Now let me take this a3 into e raised to minus I pi by 4 as a constant, say a, divided by root p into e raised to I is taken out as a common factor for these two terms into 1 by h cross integral x2 to x pd x prime plus pi by 4. See x2 to x pd x prime plus pi by 4. Now this can have a de Moivre's expansion. We know that e raised to I theta equal to cos theta plus I sin theta. So that is being used here. A by root p is retained. Cos of, instead of theta, I have this quantity, and in due course I will represent it using some symbols since it's a pretty long term. Plus I sin theta, sin of this quantity is repeated 1 by h cross integral x2 to x pd x prime plus pi by 4. Now we apply the connection formulae to the wave function in region 3 so that the wave function in region 2 can be obtained. A by root p is the constant that is being taken out here. Now this is a sinusoidal oscillation representing the classical region 3. This cosine wave function needed to be shifted into an increasing exponential term, e raised to 1 by h cross integral x to x2. X is an arbitrary point here and x2 is the point here. This is how we will be applying, say, connection formulae. Plus I is there and this sine wave function needed to be replaced by means of a decreasing exponential term with the constant multiplying the decreasing exponential getting halved. So I is the constant as long as sine wave function is concerned. This is to be halved for the decreasing exponential. So I by 2 decreasing exponential is e raised to minus 1 by h cross integral x to x2 pd x prime. Now we make a substitution. Here also we have integral from x to x2 that can be clubbed with a constant integral from x1 to x2 as integral from x1 to x2 pdx prime, the overall integral, which will be a constant. I will be representing this constant using this parameter, say capital theta, that's equal to integral from x1 to x pdx prime plus integral from this arbitrary choice of x to x2 pdx prime. So that I have an intention of making a substitution for integral from x to x2 pdx prime, that will be equal to integral from x1 to x2 pdx prime minus integral from x1 to x pdx prime. So that from this point, say x and x2, I will have a shift to x1 and x, and in the very immediate step I will be again applying connection formula so that I will get a wave function representing the region, say 1. So we will make this substitution for integral from x to x2 pdx prime in terms of integral from x1 to x2 pdx prime and integral from x1 to x pdx prime. Then phi 2 becomes a by root p e raised to 1 by h cross integral x1 to x2 pdx prime minus is there, that is being taken as a second exponent term e raised to minus 1 by h cross integral x1 to x pdx prime. Now onwards I'll label this as say capital theta as I have told you, plus the second term is I by 2 is here e raised to minus 1 by h cross integral x1 to x2 pdx prime. If this is positive, it is being labeled as a theta. So if it is negative, if the power is negative, definitely this will be 1 by theta e raised to 1 by h cross integral x1 to x pdx prime. There are two different minus signs that will make this term say positive in power. Now a by root p, this is labeled as theta e raised to minus 1 by h cross integral x1 to x pdx prime plus I, this is 1 by theta, so I by 2 theta e raised to 1 by h cross integral x1 to x pdx prime. Now again we apply connection, so we have now reached the first turning point, say x1. We require the wave function in the region 1. For that again we will have to apply connection formula for the wave function written in region 2. Then we will be applying again connection formula. We obtain then the wave function in region say 1, that is phi 1, which is equal to a by root p. Theta is the constant and this is a decreasing exponent. This is to be replaced by a sinusoidal oscillation with constant multiplying the sine oscillation being twice that of the decreasing exponential. So I have a multiplication by 2 here. Sine of 1 by h cross integral from x to x1 pdx prime plus pi by 4. I'll label it say m from the next step onwards plus I by 2 theta. This increasing exponent needed to be replaced by means of a cosine wave function with no modification for the constant. Constant I by 2 theta is repeated. Increasing exponent is replaced by cos of 1 by h cross integral x to x1 pd x prime. I have forgotten a pi by 4 plus pi divided by 4. That is, now we substitute a as a3 into e raised to minus I pi by 4. Here e raised to minus I pi by 4 is multiplied here, and here a3 is written here. 2 theta is already there. This is now sine m. Sine m can be written as say sine theta using de Moivre's theorem. As you know, sine theta equal to e raised to I theta minus e raised to minus I theta all divided by 2i, and cos theta equal to e raised to I theta plus e raised to minus I theta by 2. Those substitutions are being made here. So this is sine of m. M is this entire quantity. So again in this step I have repeated this term itself, e raised to 1 by h cross. So instead of 1 by h cross I will have I by h cross integral x to x1 p dx prime plus pi by 4 minus e raised to minus I theta. Instead of this I have put here m divided by 2i into this a parameter will give me a3 and e raised to minus I pi by 4. And for this term I by 2 theta is retained, cos theta is e raised to I theta plus e raised to minus I theta by 2. I have a lot of theta parameters here, so that is why I have labeled it m. That labeling is not necessary, it's only for the sake of convenience. Divided by 2 into e raised to minus I pi by 4. Now there are two terms, one containing e raised to im, another one containing e raised to minus im. So we take them together, and before that we will be opening this bracket using e raised to minus I pi by 4 as well. For this term e raised to minus I pi by 4 and e raised to plus I pi by 4 will be vanishing, whereas for this negative term e raised to I by h cross x to x1 p d x prime minus pi by 4 plus pi by 4 plus minus I pi by 4 make it minus I into pi by 4 plus pi by 4, that is minus I into pi by 2. Minus e raised to minus I pi by 2 is cos pi by 2 minus I sin pi by 2, that is minus I. So in this term there is a scope for minus I, this term. In the exponent term with negative power there is a scope for minus I here as well as here, whereas in this term this pi by 4 parameter will be going. So let me take this term first, e raised to I by h cross integral x to x1 p d x prime plus pi by 4 minus pi by 4, make pi by 4 getting vanished. What remains is I by h cross integral x to x1 p d x prime, that is being labeled as a q now onwards. For this step I have taken this as it is, and the coefficient is 2 vanishes. I in the denominator is minus I in the numerator, so minus I theta into e raised to I by h cross integral x to x1 p dx prime minus this second term is e raised to minus I by h cross integral x to x1 p dx prime into this expansion that I have told you, which will make it say e raised to minus I pi by 2, which is minus I, that is written here, plus I by 2 theta into 2 I by 4 theta e raised to iq. See, this term is labeled as a q plus e raised to minus iq into minus I. Now let's take e raised to iq, the positive power terms together and the negative power terms together. The positive power term here, once it is taken out, the constant part becomes minus I theta, plus in this term e raised to iq is taken out, what remains is I by 4 theta into e raised to I by h cross integral x to x1 is here p dx prime, plus, and the second term get modified as you have minus I and minus sign here, minus minus make it plus I. Upon opening this bracket you have I coming from the bracket and minus I theta here, making it minus I square theta. Minus I square is plus 1, so the coefficient for this term will be theta, and for this term this coefficient will be minus I into plus I by 4 theta, that is minus I square, which is plus 1 by 4 theta. So theta plus 1 by 4 theta into e raised to minus exponent term. that is a3 by root p into theta plus 1 by 4 theta e raised to I by h cross integral x1 to x p dx prime. See, this term is